Okay, got it.
Good afternoon, everybody. I would like to welcome you to the November 8th 40 Mile Watershed Alliance meeting. I see that we've got the Zoom setup all set up and confirmed. I want to welcome the people attending with us. I see Colton's name up there. Tracy, how are you today? And we have some special guests. Heather Dayton is here with her students. And Heather, welcome. I hope you enjoy the meeting today.
Thank you. We're really excited to be here. The kids are just coming in from recess. And again, we're just listening in. We just finished up our conservation unit. The students are submitting conservation posters. I have to leave my video camera off just for privacy, to honor everyone's privacy here at school. But we're really excited to just be listening in and hearing these great discussions.
Okay, great. Well, I hope you enjoy the session today. So also we have Rachel White here, our natural resources education supporter. So roll call. To my right,
Ben Kowski, Phil Rockenbach,
Dave Trudeau.
Don Easton.
Karen Kvotec.
Barbara's not here today. Barbara's our secretary. She normally would be taking notes. Any volunteers for taking notes? Otherwise, I'll do it.
I'm sure I can do it.
Okay, I'll take notes.
Yeah, I'm not sure how to do it. I would do it.
All right, really good. So there might be a few pauses while I jot things down. But, so we do have a quorum if needed today. While we're doing that, have you all seen the minutes for October 11th? Yes. Okay. Do I have a motion for approval?
So
second.
I'm still doing notes. Sorry, I'm slow. All right. Next category is announcements. And I know Karen's got one. Let me get this out of the way so I don't forget it. We started something new, and I don't know how well you can see it, but we want to recognize the people who have been really helpful to our 14 Mile Watershed Alliance. And so this is one of the awards that we're giving, and we're giving it to Heartland Farms. Some of you were able to enjoy the tour that they hosted for us, and they really taught us a lot about what some of the more progressive agriculture neighbors are doing. And so we want to recognize that. So they're friends of the 14 Mile Watershed. We've done something similar to a lady named Joan Kramer, who lives up the watershed and has been really supportive of us. And she gives us access to her property when we do our watershed testing. So we wanted to recognize her kind nature. And we've also done one for Owen Rock Cranberries. And some of you were on the tour a few weeks ago where they took us out on the harvest and explained to us what they do for watershed conservation and also water quality. So as we recognize groups or individuals who have helped us, we want to do these awards. So anyhow, here's an example of one. One of the announcements I would make, I just heard that Wisconsin Lakes is having their annual membership meeting on December 7th. It's open to anyone who would like to take part in it. There's no cost involved. You just need to pre-register, get an idea of what they've accomplished this year and what their plans are for the upcoming year. So again, that's December 7th. I think it's at 4:30. And just register beforehand and you can join them. And then two more things, and then I'm going to ask Karen to talk about something. December 13th is our next meeting. True Water Mullen from the DNR is going to be with us. The DNR does a lot of social programs, also how we reach out to members within our community. So he's going to come and talk with us about engaging with the community. And then the other thing I would talk about, I just know a little bit about this, but I happen to be in a meeting, actually with Scott Bordeaux. So Scott, if something comes to mind about the reorganization that we heard about, Adams County has decided they're going to do a reorganization. Anna, you would know about it too. So between the two of you, please help me out here. They're reorganizing a couple of departments, and so what they're doing is they're combining land and water with planning and zoning and GIS under one department head, and that'll be Dustin Grant, who most of us know. We've seen him here. He's joined us. Dustin runs currently planning and zoning, so he'll be the manager for those three departments. And so Kason Morley, who many of you know, has announced he'll be leaving us on, I think it's the 16th of November. And so that position then opens up. So a couple of changes there in discussions I've had with Dusty and also with the county administrator, Cynthia Haggard. She indicates we should see no difference in terms of our relationship with those groups. So anything you'd add, Anna?
We're just trying to make the reorganization as smooth and comfortable for everybody as possible. So, I mean, everything in our department is continuing on as it has been, so we shouldn't see any besides new people coming on, which is always a good thing. So
Scott, anything?
Do you know, are the like the committees, like the Land and Water Committee and Planning and Zoning Committee, are those remaining separate, or?
they're remaining separate. So yeah, still two separate meetings.
Anything, Scott?
The only thing they had was, this was slated for a January transition, but due to, I believe, Kason leaving, they're pushing that up to like a November transition.
Right.
So I just want to let everybody know, we had a great season, as everybody knows, at the Rome Farmers Market, which was over in the town square. I just got an email saying that we're going to do another one for the winter. There's only 5, so it's going to be once a month. And it actually starts December 3rd, which I won't be able to attend that first one. I'll be unavailable that day. But if anybody can do it, please let me know. So if anybody wants to do it, I don't know where it is. I've sent her an email asking her where. But if anybody's been to is it here?
But that's what I would guess.
The town hall? Oh, they would know?
That's what I would guess in the town hall.
Yeah, I would guess it's a town hall. They're telling us that it's limited space, so that makes sense. And they said that we would have to, of course, bring all of our own stuff. So we'd have to bring the booth stuff and set it up however we'd like to do that. So I'm guessing we don't have to do the canopy. We would just have to do the table and that kind of stuff. So, which is the canopy is the hardest thing. So if anybody can do that, let me know. It's December 3rd. The second one is January 14th, February 11th, March 11th, and April 8th. I thought I couldn't make the January one, but I might be able to. So if anybody wants to do it with me, let me know. I should be able to do some of these other ones as well. So please let me know if you want to do it. Again, it's a great opportunity to give our information out to the local people and let them know what's going on. That's it.
Okay, thanks, Karen. If you want to send something around about that, give our group and maybe others a chance to think about it.
Sure.
Thanks. All right, now I get to introduce Dr. Paul McGinley from UWSP, University of Wisconsin, Stevens Point. And Paul heads up the water quality group. And we've asked Paul to come and speak with us again. We've had the pleasure of him speaking with us a few times before. And what we wanted to dig into a little bit today is something called land use modeling, which is important to us because in our 14-mile watershed, we have recreational users such as us. We have agricultural groups, forest groups, municipality upstream. And so we wanted to understand in the 90 element plan, which is our restoration project, how the modeling is really calculated and determined, and then understand a little bit about nutrient loading, where it comes from in the watershed, what the source of the nutrients might be, And also a little bit about testing. How do we test for that? And what are the recommendations for us moving forward? So anybody else have anything they would like to know from Paul? Paul, I know that you're very flexible in your presentations. And so if we have Q&A, you don't mind if we pop in, I presume?
I would hope. Hey, can you hear me all right first, Don?
I hear you fine.
Okay,
Yeah.
good. Thanks. Yes, I would hope we could be very interactive today in this discussion. And as you were laying out the goals for that talk, Don, that was pretty ambitious. And I think I tried to do a few of those things in there, but I'm not going to have been able to do them all, I think, is maybe in the detail that you were describing. So that's where I would really encourage us to, as we go through this, stop, slow me down, try to interrupt. And yes, let's try to be really informal about this. Okay, so with that, I am going to trying to share a screen here. Let's see if I can do that. How we doing? Look okay? Look like the 14-mile watershed?
No.
Okay. Well, first, with that as an introduction, I do really appreciate the chance to join you this afternoon, and I really like the Zoom format. That's very convenient for me today, so that I really appreciate you accommodating that too. It would be fun to be there in person, and as Don mentioned, we've done that a few times, and hopefully we'll get to do that again in the not too distant future. What I tried to do today was, in the next 20 minutes, try to make a couple of observations about lakes and a couple of observations about land, and trying to weave in some discussions about modeling. And hopefully we can get into some of those specifics that Don, that you were kind of reaching for there. And then, time for discussion as we go along. And let me end with the final idea that maybe we're really just going to get started. I've been involved, and our program has been involved. As Don mentioned, I'm with the University of Wisconsin Stevens Point. I'm actually in an extension center that's on campus in Point, and we've been involved in projects in the 14-mile watershed or the Tri-Lakes region for decades. And so we've got, I guess, we've done a variety of smaller things there, and this was kind of fun putting together some ideas to try to think about the watershed overall, and its connection with the lake. I did make some decisions I want to present, and so again, I'll say it, redirect me as we go along, and hopefully if I don't use up my 20 minutes talking on the first two slides, hopefully, as we go along, redirect as we do that. All right, I'm going to go to the end of the watershed to start, and then kind of work my way up the watershed and just make a couple of comments about lakes. And that is typically, are often our interest when we're thinking about watersheds. And of course, the lake is really downstream of the watershed, and it takes that water, and it takes those nutrients, and it really ends up creating this biological activity when we just add light, and we're making algae, and the small animals eat the algae, and the fish eat the small animals, and we're creating this system that we cherish so much, the lake environment, and we're very interested, or keenly interested, in what we often call water quality, which is really sort of a lot of that kind of together, and in thinking specifically about how this leads to a lake system that we really appreciate and enjoy. That's kind of the simple story, thinking about phosphorus and nitrogen as key elements driving the biological productivity of the system. We put sunlight in there, and there's all kinds of plants and algae that can turn those nutrients and that light, pull carbon dioxide out of the atmosphere, out of the water, and then create this biological productivity that fuels that system. We can make this extremely complicated, and I'm not going to go into a lot of detail here, but maybe we get into that in some of the questions. In that, I'm referring to them as algae here, and it's really a combination of a variety of algae types, and some we would think of as maybe blue-green algae, which of course is a distinct category. They have different growth rates, different edible in a different way to the small animals, the appearance of the lake, they behave different in the water, they show up at different times of the year. And I wasn't gonna dig into that real early, but we can talk more about that if we have questions about some of the details about what actually goes into the lake when I put the nutrients in the lake. Before we get into that, let me make a couple of comments. And I know you talk about this in many of your meetings, but just a couple of comments about trying to classify a lake based on the amount of biological productivity in the lake. And we use terms like eutrophic or oligotrophic to describe essentially that nutrient level in the lake and how that translates into different amounts of biological productivity that we then observe with things like how deep I can see a Secchi disc in the water, or what the density of algae is in the water that I might measure by something we call chlorophyll. And so this is not a new concept. In fact, this is a very old table here, but I'm just bringing this in here as a little bit of an introduction at the start, and thinking a little bit about that range. I think you can probably see me kind of moving my cursor around there. That range of, say, nutrient levels or nutrient concentrations in the water, in this case, phosphorus concentrations, that represent sort of a range of biological productivity. And so going from, say, a phosphorus concentration of, say, 10 micrograms per liter up to 100 micrograms per liter means it's a tenfold difference in concentration, but it leads to a dramatic difference in biological productivity, where I can see down in the water, this is in meters, so 13, 14 feet into the water versus maybe just a half a foot into the water. And so that's that range of productivity, the amount of algae I'm really generating, driven by that concentration of phosphorus in the water. So going from a kind of an oligotrophic or a small amount of nutrients to just a very large amount of nutrients. And of course, that's what this is all about to some extent. A lot of this is about, right? We look at lakes, we look at the water quality, if you will, or the appearance of the water. A lot of times we're looking at that density of algae in those lakes. And here, just looking at a couple of Wisconsin lakes here, going from a 20 to 100, right? So not 10 to 100, but 20 to 100, and that difference in the amount of algae that we see in the water here, just is based on that green color of the water, going from a very blue to a very green as we go from 20 to 100. Okay, so and so now maybe get into a little bit specific. So I went to the DNR SWIMS database, pulled some data from Sherwood, one of the sampling locations, that so-called deep hole site, and I'm plotting up that phosphorus concentration here over time, over the last 20 years. And we can see that we've got quite a bit of variation in the phosphorus concentration, and within a given year. We'll talk a little bit more about that. And we can see that the concentrations are certainly in a place where we would say, well, we're relatively biologically productive here. We're looking at concentrations of 40 or 50 micrograms per liter at certain times of the year. And that's, of course, at this one spot, and it's in a deeper spot in the lake. But there's, of course, a little bit more to this, right? And when we look at all of those concentrations, and we look just on the day of the year that they were collected, in other words, all 20 years worth of data on one graph, not showing anything from year to year variation, but just saying if that sample was collected at the end of March, that's kind of around the 90th day of the year, or if it was collected at the end of August, we're in 200 and some days of the year, and I'm plotting them, their phosphorus concentrations versus the day of the year. And I think we can see is much scatter and variation there was in that previous graph, just when there is kind of a systematic trend, right? That phosphorus concentration is lower in general on day 123 than it is on day 250. And these are months, these are correspond to these different months on the top here: March, May, July, September, and October, right? So I'm looking at these phosphorus concentrations are plotted over here on the y-axis. So that's 20, 30, 40, 50, 60 micrograms per liter going across here, and then day of the year across the bottom. So, pretending that we're doing a Zoom class, How can we explain this? John, since I know you're in the class, any thoughts on that?
More heat, average temperatures would be higher, probably vegetation in its growing cycle would probably be at its prime about that time.
Right. You know, we're talking about biology here. So yeah, the warmer conditions could certainly probably lead to more biological growth. We also have in lakes like this, you know, we talk about that, you know, we didn't really spend a lot of time on that first slide, but we're going to talk a little bit as we go along about actually some of that phosphorus that's in the lake coming back out of the sediments and getting back up into the water. And certainly it's possible when we're thinking about the summer, you know, we're in a pretty sensitive time with respect to concentration, because the flow often moving through the lake is probably lower. The water spends a longer amount of time in the lake. And so any inputs of phosphorus I have during that period of time might translate more dramatically, if you will, or significantly into influencing the concentration of the phosphorus in the lake. And again, I hope I didn't make it too clear at the start, but I'm trying to be a little bit general and sort of kind of a broad brush and getting us to maybe think a little bit about some of these concepts, in addition to thinking that when we talk a little bit more about the modeling. But okay, so thinking about our lake, then we're interested in phosphorus concentration, for instance, because that often drives the biological productivity. And yet when we look at that phosphorus concentration, there's quite a variation from year to year and certainly within years. So something we're going to want to consider when we're thinking about this. Okay, so we talked a little bit about modeling. We talked a little bit about modeling land. We'll talk a little bit about modeling lakes first, though. So when we talk about modeling, we're trying to develop some type of in this case, it's going to be a mathematical representation of the system that we're interested in, the lake or the watershed, and then trying to use inputs or information to try to attach some numbers to these things. And so in this case, one of the things I might be interested in, and don't worry, I'm not going to do it. We're not going to have a lot of slides with a lot of numbers. We'll have a few, but not very many. So thinking a little bit about modeling that concentration in the lake, I might be thinking about it in terms of a so-called mass balance approach. If I could figure out the mass of phosphorus coming into the lake and the mass and the amount of water coming into the lake, and I could think of what happens to the phosphorus in the lake. Is it being incorporated into algae? And are some of those algae then being consumed by other organisms? And then some are actually settling to the bottom and disappearing from the water. We mentioned that release that we were just talking about, warmer in the summer, phosphorus released from the sediment coming back up into the water. And then some of that phosphorus, of course, is leaving because there's water leaving the lake. And so I could try to quantify these. And that's a typical modeling approach for a lake would be try to quantify all of these different arrows on this figure and then try to use that to figure out what that phosphorus concentration is going to look like in the lake, and then maybe also over with time. Okay, we're moving quickly, right? How do we do that? Before I move on to land, do anybody want to make a quick comment or question? I mean, I will come back a little bit to phosphorus concentrations in lakes, but
May I ask a question? Why is there no trophic state index for nitrogen? Is it possible? I mean, we have clarity, you know, the Secchi disc, we have phosphorus, we have chlorophyll. Well, nitrogen's missing.
yeah, that is a great question, and I'm going to put a question at a slide at the very end to provoke a little bit of a discussion too on this. But well, one, I'll start with maybe probably a basic answer to that, or what some would say is an answer to that, and that is that the our interest here is really biological productivity. So how are we turning sunlight and carbon dioxide into algae, and the rate at which that's going to happen is we're going to require nutrients for that to happen. But if there is a nutrient that is in short supply and everything else is relatively abundant, it is going to be that concentration of the nutrient that's in short supply that really controls the productivity. And that in most of our inland lakes, the observation over the last well, since the 70s, when this was somewhat controversial, has been that phosphorus is typically the element that's really in short supply. So everything else is reasonably abundant. And if I tweak with the phosphorus concentration, if that goes up, the amount of algae goes up. If the phosphorus concentration goes down, the amount of algae goes down, because they're not missing anything else. So I think that's probably why we really have that now. I will say, and I think we're going to see continued interest in this when we look at lakes that have very high nitrogen loading. Are other things happening? And we do know. I mean, you know, we talked a little about complexities at the start, that you may be selecting for different biological communities if you have different ratios of nitrogen to phosphorus, or if you have different forms of nitrogen or different quantities of nitrogen. Now, it's complicated, and I'm gonna try to point out one reason why I think it is reasonably complicated when we get to the end. But that's a great question. So maybe stay tuned, right? In a few years, maybe we'll know. Oh, we'll continue to know more about that. But that's a great question.
Thank you.
Any other? And how do I do it? Does that seem like a reasonably satisfactory answer? We should keep discussing that.
I'm satisfied.
Yeah.
Okay. Any other comments or questions about lakes? We'll come back to lakes though. So.
Well, I do have a quick question. I noticed on your graph that the total phosphorus was relatively low compared at least to the summer months during the springtime. And I'm wondering if you could explain a little why that might be, given, you know, we know that's usually a time where, you know, you get a lot of rain, the crops aren't growing quite yet. So, you know, we tend to get quite a lot of sediment loss into our streams and rivers and things like that. So, you know, wondering if you could kind of explain why that lag occurs.
Yeah, that's a good question. And I don't know if I can entirely explain it, but we can throw some ideas out there. So, you know, there was a study done in 2017. I didn't, or in 2014, 15 or something like that. And I didn't mention that it is one of the sources of information that I used in putting together some of these slides that measured concentrations. And I know you guys are measuring concentrations of phosphorus in the streams. And, you know, what are you typically finding for phosphorus concentrations in the streams in your watershed monitoring? Total phosphorus. Anybody got a number that pops into their head here?
Don't have a number. It's often higher in the stream than it is in the lakes, as if there were some sort of filtering effect as the water moves through the lakes, or sediment effect. But I don't, a number, I wish I had my graphs.
Well, and I've got some comments on that too later. Yeah, no, okay, no, that makes sense. So yeah, but I would agree, right? It isn't, you know, typically you're not seeing concentrations that are extraordinarily high in the stream, right? I mean, I'm going to get a ballpark, you know, thinking about the units that we were talking about for the lakes. So maybe 40, 50 micrograms per liter, maybe something like that in the stream.
Yeah.
And you're right. And that's typically going to be greater than the concentration, typically greater, at least than when we see in the lake at some times of the year. And one of the explanations for this, and it goes a little bit to the lake modeling. So I'm going to slip back to this slide. One of the things that was observed early on in lake modeling was that if you take that amount of phosphorus and that amount of water entering, this essentially then is the concentrate. If the only source of phosphorus was a stream coming into this lake, these two together, phosphorus entering and water entering, is really the concentration entering. So if that was something like 60 coming in, and then a portion of that is incorporated or used in the lake, and then a portion of that actually drops out because we're incorporating that into biology, we're incorporating that into cell material, and then some of that ends up in the bottom, maybe not gone forever, right? That gets a little bit to this phosphorus release when it warms up in the summer and it comes back up into the lake. But at those times of the year when I'm settling it, or where I've got some loss, or some of this is associated with sediment particles and it settles out, I'm going to typically see a lower concentration in the lake than I'm probably going to see coming in. This particular lake, a lot of times the water doesn't spend a long time in the lake, so we may not see an enormous difference between the two compared to a lake maybe where the water's spending years in the lake. You know, here we're spending months in the lake, but we're certainly going to have some loss. And so thinking about, you know, going to specifically to that question, it does seem like in this lake, and and not necessarily uncommon for relatively shallow, relatively biologically productive lakes, we've got that release term coming out of the sediment, which is usually driven by warm conditions later in the year, or at least aligns with warmer conditions later in the year. My higher concentrations are going to be those times of the year where I have a significant sediment release component, and that other times of the year I'm going to see kind of that lower concentration because I'm not really driven by that internal. I've got some other theories I'd like to propose to you later on that question, but that would be I guess an initial reaction to that question, and we're going to come back to that. So keep that question in mind. All right. With that, I'm going to kind of move us along a little bit to the land side of this. I want to make a couple of comments about land, think a little bit about watershed modeling on the land, and maybe to some extent get into those details Don was talking about, but maybe just getting a little bit more of a broad brush approach on that. All right, so thinking about the land, right? We've got the 14-mile watershed here, and we know that the water in this watershed, or the general pattern of the water flow in this watershed, is from east to west. And one of the reasons we know that is because we can measure the water level in the ground in that watershed. We can sink wells in there. We can measure the level of the groundwater, and we know that the groundwater on this east side of the 14-mile watershed is around 1,100 feet above sea level. And we know that the water level in Sherwood over here is what, around 1,010 feet above sea level, something like that, 1,015, something like that. No one is disputing that, right? So far?
Sounds good.
Sounds good. Okay. I mean, which is remarkable in itself, right? We're 1,000 feet above sea level, right? So that's 1,000 feet above the water level. That's 400 feet higher than the water level where the Wisconsin River enters the Mississippi. So, this water is pretty high, but so is all the other water up here. That's why the water is flowing downhill. But we have about 100-foot drop moving from the eastern side of the watershed to the western side of the watershed. And then this area is dissected by these ditches and streams. And so they are the low spots that then that water flows into. And so then the water is draining out of here and showing up in the lakes, right? So we've got this difference of elevation from one end to the other. Why do we have that difference of elevation from one end to the other? It's because we are sticking water into this system every year. And so I have to, thinking about modeling, I have to make a couple of comments about how much water is moving through the 14-mile watershed. And so maybe just a quick question. How much rain on average do you get in the 14-mile watershed every year?
33 inches.
33 inches, something like that. Okay. And I'll say 32 because that's what I put in the slide here. But yeah, 33. Now, the last couple of years, we certainly have had more rain than that. And we can talk about the implications of that. I will contend that most of that water, or a significant percentage of that water, ends up going back up into the atmosphere as what we're going to call evapotranspiration. It's used by the vegetation. While that moisture is available in the soil, the plants take it up, they move it up into the atmosphere. Anybody got a rough idea of what the depth of, or how much of this 32 inches every year gets used by the plants in evapotranspiration?
Around 20 something.
Around 20, something like that. You guys, this is a great Zoom class here. So yeah, around 20, 22, something like that. So I'm going to put 22 in there because that's what I have in the slide. So I think an important thing to remember in these watersheds is that means that every year, at least about 10 inches of water is actually probably leaving the watershed. I already have a bunch of water in the groundwater out there, and that level of the groundwater is reflecting the fact that I have had this difference between precipitation and evapotranspiration for many, many decades, hundreds of decades. And so now I have this water system where I have more water coming in than is evapotranspired. And so I have to kind of move that water out. Well, that's the water that's draining to the streams, that's draining to the lake, or the lakes. And so that's really about 10 inches roughly. I mean, it's going to vary from year to year, right? But if we get more rain, maybe this goes up a little bit, but then this number will certainly change. Or if we had less, this may change a little, but this is certainly going to get lower. But something like 10, on average, 10, 11 inches of water a year, which if your watershed is 65, 70 square miles or something like that, and I'm just pulling a number out here that looked reasonably, and we can talk more about getting more specific on that, but that is a volume of water. So 10 inches a year across around 70 square miles is actually 12 billion gallons roughly of water every year, which has to somehow get out of the watershed. Or if it doesn't get out of the watershed, the water level in the watershed is going to be going up and up and up. But the water level is somewhat constant. We can talk a little bit about year-to-year variation, but I have this 12 billion gallons that is getting out of the watershed. It doesn't all come out at once because most of this precipitation is hitting relatively sandy ground and that's working its way into the soil. It's fueling that water table or adding to that water table, which then ultimately is draining, and it takes some time, right? So not all the water in the ditches or in the stream this year is water that came as rain last year, right? Some of this is 10, 20, 30 years old by the time it works its way over those ditches, but it's essentially replacing that water that's coming in this year by moving out into the streams or the ditches and showing up in the lake. And this 12 billion gallons, and if that were to slowly come out over the course of the year, that would be roughly equivalent to around 50 cubic feet of water every second, which, we don't, I don't have data that tells me how much water is flowing into 14 Mile into the lake every year, but I do know your neighbors to the north at 10 Mile, there is a USGS gauging station, and that's maybe something around 70 square miles also. And if I look at the flow coming out of that watershed, or at least going past that gauging station, it is 70 square miles or so, and not far off from 50, 60 cubic feet of water per second. It goes up certainly in those wetter portions of the year. It is lower during the drier portions of the year, right? Periods of the year where maybe I'm certainly getting a lot more of that evapotranspiration, and so some of that precipitation isn't immediately going into the water table. Other times of the year, I'm not really using that water, and a lot of it's maybe moving down to the water table and kind of pushing that water into the stream. A variety of mechanisms that lead to higher flow in the spring and fall than I get in the summer. We can see that I'm really getting a flow out of your watershed and that watershed that's consistent with that. And it really is a model in a sense, right? It's that precipitation coming in, what I lose to evapotranspiration, the rest kind of shows up in the stream and shows up in the lake. How are we doing? Question on that? Comment? Does that make sense? Do you believe that?
Yes.
Totally.
I mean, it is pretty amazing in a way, right? That is a lot of water moving through these watersheds. We're sticking, that difference between precipitation and evapotranspiration leads to a fair amount of water. That's of course an important part of the Wisconsin water resource system is that we are moving a lot of new water into the system every year. Well, taking this back to nutrients then, now we've got a system where we're putting all of this water through it. We're concerned about nutrients like nitrogen and phosphorus because the concentrations in the lake determine the biological productivity. And the interaction then of this water with the land is an important part of moving the nutrients into the water and into the lake and then driving that biological productivity. And I think one thing that I find interesting when I'm thinking about this is really, and thinking about phosphorus now, and we'll talk a little bit more about nitrogen, thinking about that, how much phosphorus there really is on land. I mean, phosphorus is a biologically essential element. It is in reasonably scarce supply. And so when phosphorus is available, biological organisms will take it up. But because we have a lot of, and it's also fairly reactive, so it will stick to soil, it will stick to mineral particles, it will stick to sediment. So that when we start to add it up, when you grab a handful of soil, or you start to analyze the tissue on some plant material, and you figure out what the mass of phosphorus is on the land, it's an incredible quantity of phosphorus. I mean, these are just some ballpark numbers. It came from a study that was done decades ago that was actually in a wooded area, and I don't think the numbers would be much different. They would probably be a little bit higher when we're thinking about some of our more um, active agricultural systems where we got higher inputs and we also have some outputs of phosphorus. But when we start to work out the math on this, we're talking hundreds of thousands of pounds of phosphorus per every square mile. And so I'm putting all of this water on the land, and it's flowing through a system that has a lot of phosphorus in it. And of course any of this phosphorus that water acquires and carries to the stream is then going to be driving the biological productivity of that stream and in that lake. And so anything when we're thinking about the movement of nutrients in your watershed, to a large extent, we're thinking about where's the water moving, how's the water moving, and what is the availability of the nitrogen and phosphorus when it encounters that water. And so thinking about this from a modeling standpoint, we might be interested in thinking about the concentration of that phosphorus in different parts of the watershed when the water coming through the system is interacting with the phosphorus on the land. And we might want to just think about that in terms of some concentration. So I'm going to just try to generalize it here and think about two types of systems. One system where I have, and it's shown here as an agricultural system on the right, but I want to say that's a system where the water is actually moving across the surface of the land. So whatever that system is, an agricultural system, an urban developed system, a suburban developed system, something where I'm moving the water in a pathway that takes it across the surface of the land. And then on the left, looking at a forested area with a significant duff layer or layer of leaves and very porous, light, fluffy vegetation or organic material, and then an undisturbed soil under that, where the water is going to have a tendency to move vertically through that. It's not going to run across the surface. It's going to run vertically down. And it's going to, in both cases, the water ends up in the stream, right? Because the stream is lower than the land and the water is flowing downhill. But in the one case, it goes down into the groundwater, flows with the groundwater on the left, and then on the right, it's flowing across the land and it's interacting with the soil and vegetation, which we know has a lot of phosphorus in it. And so we can kind of generalize this. And again, this is a little bit general, and the range is somewhat wide. But if I think about that water that's moving through the land and down to the groundwater, phosphorus is a sticky molecule. Phosphate is a sticky molecule, or it's going to be attached to sediment, and that sediment is not going to percolate down through the ground. It's going to be filtered or trapped. And so by the time I get down to that water table, under normal conditions, get to that groundwater, I'm probably not going to have real high concentrations of phosphorus, and I'm using a number here of 0.02 milligram per liter, right? Which would be, thinking about the numbers we're using for the lake, we were actually in microgram per liter, and sometimes this units can be conversion, but that'd be confusing, but that'd be the equivalent of 20, right? So 20 in our lake units. I'm thinking about a groundwater concentration of phosphorus of 0.02 milligram per liter. That's the same as 20 micrograms per liter, which is the units I'm using for our lake concentrations. Whereas I look at the surface runoff, the water that's running across the surface, interacting with the vegetation, interacting with that hundreds of thousands of pounds of phosphorus on the surface, and no mechanism to really filter the phosphorus out before it ends up, flowing in that channel. I can easily, through that combination of vegetation and sediment that's in that water, get up to 1 milligram per liter, certainly 0.5 milligram per liter, or 2 milligram per liter, or 3 milligram per liter. So thinking of in our lake units, 1 milligram per liter is equivalent of 1,000 micrograms per liter. So we've got this, this 20, 30, 40, 50-fold difference in phosphorus concentrations between these two different pathways. And I think when I'm thinking about modeling, when we think about modeling the land, a lot of the watershed modeling is really trying to get at this distinction. It's like, okay, what in these different types of land management activities, how is the behavior of the water and the availability of the phosphorus influenced by what we're doing on the land? And then trying to decide, okay, is that water that's moving across the surface that's going to have a high concentration of phosphorus? Is that going to have a low concentration of phosphorus because the water is actually moving vertically in that system, getting down to the groundwater and then traveling to the ditch or stream that way? So I'm trying to come up with, again, thinking about our lake model, right? We want to know how much phosphorus is coming in and how much water is coming in. And I'm thinking about trying to model the land side of that. I'm trying to think about how much phosphorus per time, say pounds per year, per some area, per an acre or per field or something like that, which is really the concentration in the water times the amount of water that's in that pathway.
Hey, Paul, I have a
Yes.
question.
Yeah, that's good. Yeah, thanks for barging in. All right, go ahead.
So in my somewhat simplified view on this, I had come to believe that nitrogen typically will move in the water. Phosphorus attaches itself to molecules of dirt or whatever. So understand the graph, but with phosphorus that flows into our lakes or flows through the watershed, is that attached to like, let's say, dirt or silt in the water? How is it moving, let's say, through the water or through our lakes?
Yeah, good question. And I would say probably a combination. I mean, when we did that work with you and Adams County in that study a few years ago, when they were doing that stream monitoring, that's, I guess, the data that I'm most familiar with. We were measuring something called total phosphorus, and also some measurements of so-called soluble phosphorus. In this case, it was soluble reactive phosphorus. But the difference here is that to get the soluble, you run it through the filter. You run the sample through a filter, and then you measure the phosphorus in the water that comes through the filter. Whereas the total, you just take the sample and we process it. We add some reagents to try to release all the phosphorus from the cells and things that are in there. And in a lot of this, it's a little bit of a mix, right? A portion of the phosphorus is soluble phosphorus, but a lot of it shows up in the total. So the concentrations are relatively low a lot of times. I mean, if they're 50, 60 micrograms per liter in that stream, we could go back and look exactly what that breakdown between the total and the soluble is. But I would say a lot of it's attached to relatively small particles, or we might use the term, particulate or pieces of organic matter. So some soluble and some attached to, I would say, very small solids, that are small enough where they reasonably stay in solution. They're not just dropping out. If they were bigger solids, they might not be conveyed in the stream. They might drop out on the bottom of the stream. And there's probably some of that too, and some evidence that maybe you even get the same kind of biological release from sediments in ditches that we actually see in the lakes. And so some of that gets a little bit more complicated, but some of that I think would depend on the flow. If you're really low flow, you cannot really entrain a lot of solids or particulate material in the water, because they're going to drop out of the water. If you had really high flow, and these ditches and these watersheds are not, you get higher flow, but you're not, they're just not systems that generate massive quantities of flow, because the watershed is relatively permeable. The soils are pretty permeable, but you could convey higher concentrations of particulate material if you had higher flow at times when you have higher flow in the stream. I don't know if that helps. I guess kind of I would say kind of a mix, and we could look more closely at some of the analytical results when you do both total and soluble reactive.
Okay.
Any other comments on that? Because I want to make a quick comment on the modeling. So if I was going to try to model, we'll come to your question in just a minute there. Thanks. We've got lots of choices on modeling on this. So part of it could be, and probably the most common is, something that's relatively simple. So I would, maybe an annual phosphorus loss based on different types of land use or different types of management, based on measurements others have made. And a lot of times it's based on the type of management and the soil. Is the more permeable soil, you're really going to have less surface runoff, and we know surface runoff is really a big driver of the overland phosphorus loss. But then the land management also influences the availability. Of course, we get, that's a simpler way to do it, and that's probably the place where we would typically start, and when you're starting in your work. But you could also envision getting extremely complicated and trying to follow every drop of water through the watershed. I show that as number 99 because there's a lot of intermediate possibilities in between. Okay, before I go on, how about that question that we had a minute ago?
Hey, Dr. Paul, it's Scott Bordeaux.
Hi, Scott, I didn't see you there.
Is there a magnitude difference between phosphorus attached to sediment and soluble? as far as what, the effects in the water for producing algae?
Well, that's a good question. I mean, certainly, I think we could say that if the phosphorus is in the soluble reactive form, it is immediately available, right? So that's, I mean, the test is, I mean, there's a little bit of processing in the test, but we know that's a pretty small molecule of phosphorus and probably something that some organism could probably access pretty quickly. If the phosphorus is attached to a solid, it's a little bit, there's probably a range of availability there. I mean, truly, if it was incorporated in that solid in a way that made it rather difficult to get out, except under the aggressive procedure that we use to actually release that phosphorus, it could end up in the bottom of the lake, and then maybe over time, some of that, that particulate, that form of that phosphorus that was kind of tied up in that solid, as that solid breaks down or dissolves, some of that's going to be released. But I would say, in between those extremes, there's probably some of that phosphorus is not maybe immediately available, but once it gets in the bottom of the lake, it could be, especially if it's associated with some organic matter and there's biological, we know there's biological decomposition in the bottom of the lake, that ultimately that could be re-released into the lake. So I mean, so it's a good question, and I guess I don't have a general, an answer that's, I guess, completely unambiguous there, but I think there's a range of availability, and I would, I'd be a little bit careful about just assuming anything that's in particulate form is not going to be biologically available. A lot of it probably will be. It may just take a little bit longer than if it was a soluble form.
Okay.
Does that help, Scott? Does that make sense?
Yeah.
And Paul, we
Yeah.
do have another question in the chat. Heather asks, are certain cover crops better than others for absorbing phosphorus from entering the watershed? If you could speak on that.
Oh, that's a good question. I would be, if I was thinking about the phosphorus movement from the land to the stream and thinking about the influence of cover crops, one of the things I would be really interested in is how those are affecting the movement of the water. So if by having cover crops on the land, that prevents raindrops from hitting the top of the soil and destroying the soil structure and creating conditions where I'd have more overland runoff, then I'm creating conditions where I'm probably going to have more infiltration, more water moving vertically in the profile into the soil, and less moving across the surface. And to me, that's probably thinking specifically about phosphorus, that's probably that to me would be one of the more dramatic benefits of cover crop from the standpoint of phosphorus. Now, as Don, I think, was referring to earlier, the nitrogen question is a little bit different question, because the nitrogen isn't really the compound that's probably moving across the surface in overland flow, but is in fact much more available to percolating water. So as the water moves through the soil, if there's available nitrogen in the soil, it's going to acquire that nitrogen is just going to carry it down below the plant root zone. And then once it's past the plant root zone, then it's going to end up in the groundwater. Ultimately, it's going to end up in the stream or the ditch. So I could see the advantage of the cover crop there would be if I can expand that period of time over which there's roots actively withdrawing nitrogen out of the profile and keeping that plant root zone active longer, then maybe I've got a possibility there to also move some nitrogen up into the plants and prevent it from going vertically down, right? But again, I'm getting into that distinction, which we haven't spent a lot of time talking about, but that, really an enormous distinction between phosphate movement, phosphorus movement, and nitrate movement, where the nitrate is so soluble and the phosphorus generally really isn't that soluble, although it can be traveling on some pretty small solids. Does that help on that question? Okay, thank you. All right, so I'm going to try to keep us moving along here. I don't have that many slides left, but I do have a couple of concepts I would like to spend a couple of minutes on. Maybe then we can open up for some final questions on this. in addition to the modeling, we can also measure. And so one of your historical studies a few years ago was that watershed monitoring work that was done by the county and in the lake organizations. And also there was a study done 20 years ago by Bill James and some of his colleagues looking at this, and these answers really were not a lot different. So I really focused on a study a couple of years ago, and looking, in that case, there were 3 monitoring locations set up in the watershed. So these would be a little bit ahead of the lake, so a little bit east of the lakes, but they were kind of capturing 3 different stream locations, measuring flow, looking at concentration of phosphorus. We took those numbers, kind of extrapolated flow, and also measuring sort of continuous water level, which we could then translate into flow at different times and kind of do the calculation. We said that the amount of phosphorus is this product of the amount of water and the concentration, kind of doing some calculations related to that. And we found, in those, adding up the results from those 3 monitoring locations, about 3,300 pounds of phosphorus per year, and almost 10 times that, the amount of nitrate. And by the time we add another form of nitrogen in there, the organic and ammonia type, primarily organic nitrogen, that was almost 400,000 pounds of nitrogen per year leaving the watershed. So you could go back and compare this to what you'd get in some type of modeling, say, right, you knew how many acres, you could kind of, thinking how we had talked about that before, about, okay, I could be looking at different land uses, and ultimately, I think you'd want to make sure that these 2 reasonably align, this amount of phosphorus and nitrogen that was measured, and how that aligns with what we would use in the modeling techniques that we use on the land. Okay, so and we can come back to that, but let me try to put these 2 together in just a couple of slides at the end here, and think maybe a little bit about how we can tie that watershed modeling with the lake modeling. And again, right, we know that the lake is where nutrients are driving productivity. We know the land is where the water is coming through, and the nutrient availability and the path that water takes is dictating really the amount of nutrients that are moving into the lake. And to some extent, the modeling doesn't have to be overly complicated. It's kind of accounting for the mass. What's going in is what's going out, plus what's disappearing or coming from the sediment or something like that. So let me try to do that, or at least to try to think about an example of that. And I took a relatively simple model, but I was interested in getting to that slide early on where we talked about that variation of phosphorus concentration during the season. Now that seems like a very important piece of the lake water quality question, is what happens in July and August and September in these lakes, and that phosphorus concentration is quite a bit higher than the spring concentration, as others have pointed out. And what I have on this graph on the bottom are the dots here are the different monitoring points or results from tests. And this is Sherwood deep hole total phosphorus concentration. So we recognize these these values over here, right? 30, 40, 50 micrograms per liter in the summer. And the lines on here are a relatively simple tool that takes the daily flow and really just using the 10-mile flow, saying like, oh, that's kind of a reasonable surrogate for the flow that we might have in 14 mile. And this is just meant to be as a simple exercise, getting us to think a little bit about what the utility of modeling might be, what more modeling, what more do I need to do with the modeling, and then use that in some term for release of phosphorus from the sediment and settling of phosphorus from the lake, and make that release term dependent on temperature, just as we said in one of our earlier questions. You get, it's warmer later in the summer, there's more biological activity, get more of that release from the sediment. But we're also sensitive in other ways, right? At that point of the year, we have lower flow in the lake, so additional inputs into the lake, any additional inputs I have in that low flow period of time are going to have a greater impact on the concentration in the lake. So we could have multiple drivers of that higher phosphorus concentration later in the summer. So as we just said, right, that's kind of the, in this, clearly it's when we talk about modeling, and I didn't really spend a lot of time talking about it. Model is, it's a simple representation, and these are complex systems. And so while we're not describing the location of every phosphorus concentration point in this graph, you can see where, this type of very simple, and this is similar to the model that the DNR used in some of their Wisconsin TMDL work, looking at Petenwell and Castle Rock and other places, just a model that tries to capture some of that within year variability, not just looking at the concentration as an average over the course of the year, but trying to really focus on some of those areas when I might be most concerned about the phosphorus concentration. There's certainly a long history of this idea that a warmer sediment, shallower lake system, that water can come back up into the water, into the surface of the water, and can influence biological productivity. It can influence that concentration of phosphorus in the lake in the summer. But there is another, there are other variabilities, there are other variables, and I'm going to pose one here just for discussion purposes. Thinking a little bit about those periods of year during the summer when I've got relatively low flow coming through the lakes. And that's a little bit misleading probably in the 10-mile data, because we do have quite a bit more evaporation across the lakes than we would in that 10-mile stream gauging. So we might not be capturing that entirely. It could be a little more sensitive than we even think it is. But we're also combining that period of the year when we don't have much flow in the coming in, with period where I'm actually getting a fair amount of large precipitation events. And so thinking about the influence of precipitation on the near shore and the role of big storms, overland runoff pathways, and low flow, is that how important is that to the nutrient or the phosphorus movement into the lake? And I, just because I had this information available, because I was playing around with that model and I had the precipitation, I took the Wisconsin Rapids rainfall data for the last 21 years, January 2000 through a couple of days ago, and just looked at those top 25 storms, single day precipitations. And of course, June of this year is at the top of the list, right? So 4 inches of rain, at least is what they recorded in a day. But it's also pretty remarkable to me that, we've been thinking a lot over the last couple of years, or last 10 years, I guess, about shoreline development, shoreline runoff, overland paths, movement of nutrients from land to water, the amount of phosphorus that's really on the land, and the interaction of that with the water that's moving downhill to the lake. A lot of these storms are in June, July, August, and September, and they're pretty big single day rainfall events. And an awful lot of them are actually in the last decade. So thinking about all of these variables that go into the concentration pattern that we observe in the lake, which is very elevated concentration late in the summer. Certainly, we know warmer sediment releasing phosphorus, but how much is also influenced by some of these other potential drivers that we would have of moving nutrients from land to water. This is not a subject without any research, but we were certainly involved. This is a picture. We had a graduate student a decade ago. We're still kind of working up some of that information, but some of that we have available. Who was experimenting with a simulated downspout and running water across lawns. In this case, this happened to be in Shawano Lake. That's Shawano in the upper picture up there. There was a study done by USGS a couple of decades ago, almost now. Looking at nutrient runoff across land, lawns in developed areas. And the message there is really no different than the message, I think anyway, at least in general terms, the message on the agricultural land. It's if we move land, or when we move water across the surface, we carry phosphorus with it. We just don't have the mechanisms for phosphorus removal when the water is moving across the land, and we can carry then a 0.5 milligram per liter, a milligram per liter. Again, right, that 10, 20, 30, 50-fold difference between water that moves across the land and water that moves vertically into the ground. Okay, I got to wrap this up because I know you guys have other things to accomplish in your meeting, but let me make a couple of comments about nitrogen. I wanted to talk a little bit about that. We know that in this particular watershed, there's hundreds of thousands of pounds of nitrogen that move through that watershed and into the lake. And part of this is, and this is really consistent with what we measured in those streams. I know you're doing this in your watershed monitoring, but we can measure a nitrogen concentration of 9-10 milligram per liter nitrogen on the stream next to D, right, the Leola ditch. And some of the other streams we have elevated nitrogen, and maybe not quite as high as that, but all of this ends up, of course, in the lake. And when we measure nitrate, and most of it comes in as nitrate, when we measure nitrate in that lake, it's almost the exact opposite of the phosphorus story. So here's a graph. There's a lot going on here, right? But this is month of year on the bottom. This comes from Sherwood. Sherwood's a long-term trend monitoring lake. So DNR has been monitoring, and nitrate is one of the things they have been monitoring for decades in that lake. So we got at least a pretty nice data set there. And when we look at the nitrate concentration, that's on the y-axis here. So the nitrate concentration in that lake, it's highest early in the year, in the spring, and it's lowest or almost not present at all by the time I get to the fall. So we're talking about just nitrate here. So if I'm measuring nitrate, remember phosphorus, this graph would look exactly the opposite, right? It would be relatively low over here, and it would go up in the late summer and in the early fall. So there's a lot, it's not only different on the land, it's also different in the water. And there's a couple possible, there's certainly at least a couple things that are going on here. One is that anytime I put something like nitrate into a lake system or a wetland system where I have areas of relatively low oxygen, like getting close to the sediment, I am going to be in that nitrate, that molecule can actually be used by bacteria as a substitute for oxygen. So if we're in a low oxygen environment, there's lots of bacteria out there that will actually be able to use the nitrate in the place of oxygen. And so that we call that process denitrification. And then it's actually converts that nitrogen to nitrogen gas, that nitrate to nitrogen gas, and then the gas probably leaves the system and goes into the atmosphere. That's actually it's a nitrate removal system. And I know you're experimenting with that, and we're working with others on experimenting with denitrification and trying to get that to take place on the land. It also does take place probably in the lakes and in the wetlands. But the other side of this, of course, is, are there other pathways for that nitrogen, right? The nitrogen is so biologically essential, and when it's available, certainly other plants are going to be using it. And this decrease is not really inconsistent with also assimilation by that into growing biological activity. Plants that can use that nitrogen, and nitrate is certainly a relatively available form of nitrogen, and possibly be incorporated. So this is, these concentrations, this is a little bit of a research area, I think, and that these concentrations are relatively high nitrate concentrations in the spring compared to a lot of lakes that we see. And I think, as I mentioned earlier, this is certainly an area that I think we need more work. We've got some studies going on, and something that I think would be useful to keep talking about. All right, if you don't mind, I'm going to just pop up my quick wrap up here, and then we'll have some time for questions, because I know you do have other things you want to do here. But let me just kind of run through, wrapping this up, right? I mean, reviewing what we were talking about, lakes are driven, the biological productivity in the lakes are driven by the nutrient concentrations. Phosphorus and nitrogen are critical to that. I like to make the case that the land is really the source of a lot of nutrients, and the source of the water. And so it is really that combination of water and nutrient availability and pathway that the water takes that drives that nutrient movement into the lake. And then certainly, of course, I'm just trying to, I think it's an interesting thing to keep talking about and thinking about the utility of models, thinking about that phosphorus concentration in the summer. Of course, you've been working on this, and I'm not suggesting anything new here, right? But, phosphorus is driving the biological productivity of these systems. And, without a doubt, part of that is phosphorus that's entering the lake. And, how do we keep thinking about reducing that? And I would say, an important part of that is continuing to think and look around and observe, do we have pathways for that surface runoff entering the lake? I'm proposing here in some of my slides, are we thinking enough about, big summer storms, near shore runoff, and how do we maybe think a little bit more about how we can quantify some of that? I've got some ideas. We've been playing around with that, and I know you do too. So we can keep talking about that. And then, of course, nitrogen. There's a lot of nitrogen in the system, and I know certainly from your watershed activities, something we really have to keep thinking about is nitrogen is a tough compound think about addressing, because it is so available to percolating water. You have a watershed that percolates water very well. And so anytime that nitrogen is available to that water, it's going to be moving down. It can move rapidly past the plant root zone, and then it just ends up in the groundwater, and eventually it's going to end up in the stream, in the lake. And finally, hopefully, thinking a little bit about the modeling. I tried to address a little bit of it here. I'm hoping we can keep that conversation going. And as you talk more about your modeling or questions come up on that, I'd be happy to try to help on more specific questions that relate to some of the modeling that you're working on, that you're looking at. So with that, somehow it's almost like a class length, Don. We somehow managed to go 55 minutes.
Right. Hey, Paul, a question. Are you able to share the slides with us?
I'd be happy to.
Okay, thank you. Great.
I have a question. So, so basically, there's a lot of nitrogen at the beginning of the summer, and then it goes down to zero. So does that mean that all that nitrogen is being taken up by the plants and the algae that is in the growth phase from the beginning in spring toward the end?
That is the question, isn't it? How much of it is because I think there's two pathways here, and one would be the denitrification. I mean, one of the topic areas of interest with respect to thinking about reducing the amount of nitrogen, say, going into the Gulf of Mexico, right? I mean, it's implicated in Gulf hypoxia and the reduction of oxygen in the Gulf of Mexico. And one of the things we look at there is, okay, we're getting more wetlands into the watershed, and that can lead to low oxygen conditions that can convert that nitrate into nitrogen gas and move it out of the system. That's a little bit different mechanism than incorporation into plant material, which if it was incorporated into plant material and those plants were actually rooted in the sediment and would then bring phosphorus up into the plant, that is a mechanism where I can actually, by adding nitrogen, I'm actually bringing more phosphorus up into the system, because I'm bringing it up into the plant, which then maybe that plant ends up, eventually, dying back and decaying in the sediment, but then maybe that is fueling a sediment phosphorus release the next year, right? So I think there's potentially some important implications of high nitrogen loading in both in plants this year, or some type of attached algae this year, and even recycled phosphorus the next year. So I think your question is a great one, and it's an important one, and I guess I'm interested in figuring out what the answer to that is.
Because we have a lot of plants, we harvest a lot of weeds. So we've got quite a few. So I'm just wondering if, that I'm sure some of it's going out of the system. It's probably.
Yeah, and probably, certainly some is going out of the system. Excuse me if I interrupt you, but going out of the system earlier in the year, right, when the water's moving through rapidly, right? That exchange rate in those lakes is relatively short. We didn't spend a lot of time looking at the flow, but there's a lot of flow obviously in the spring, and it's not spending that long. So some is probably passing right through the system, but certainly you get into the summer, that water is spending a relatively long time in the lake. So it's, to some extent, it's probably not too surprising that we don't really see much nitrate, because it's going to disappear one way or the other. It's going to be incorporated in the plants, or it's going to be denitrified into nitrogen gas. But going back to the plant issue, the other, you do have conditions where and sunlight is hitting the bottom of the lake. In many areas, you've got sediment. Those are conditions where you can grow plants. I think you're right, though. An important question is, to what extent is that additional nitrogen influencing that?
So is there, I'm guessing over many, many years, and I kind of learned this in lake leaders, the sediment is building up, correct, as the years go on. And these lakes have been in existence for 50 years. So I'm guessing the bottom of the lake is closer to the top of the lake now than it was back 50 years ago. Am I correct?
Well, yeah, I mean, right, if we're not removing anything from the lake, the rate at which they fill in, I guess if we want to think about it as filling in, is going to depend on the material coming in. And so if you're moving a lot of sediment into a lake, that sediment is probably going to drop out in the lake because the velocity of the water is much slower and the sediment is going to drop down and you can build that up. In your case, a lot of, I'm not sure we have a lot of evidence that there's a tremendous amount of sediment coming in. I mean, there's certainly some, right? So the other part, and I think that's what you're getting at, is if I'm growing plants, I'm making this plant material that's going to go back down into sediment. I'm going to be accumulating sediment. I mean, it goes down to the bottom of the lake. I'm going to be accumulating organic matter in the bottom of the lake. To some extent, that is breaking. Some of that is breaking down every year, but no doubt, right? If you do a sediment core, you'll find, older stuff at the bottom and newer stuff at the top. And you can make those estimates of what that rate of accumulation is. I don't, I guess that, that's kind of that's kind of a general story, I guess, on that. I'd have to look specifically if we have such information about your lake, sort of this rate of buildup.
The reason I bring it up is they're thinking of doing borings. So that's why I brought it up.
So these are borings where they're going to, because there is a lake evaluation technique they call paleolimnology, where you go in there, you do a boring, and then you look at the different algal communities, specifically diatoms, things that would persist in the core, and then they can try to use different age dating techniques to figure out how old the different sediment layers are, and then maybe infer from the biological evidence that's in there, say from those old diatoms, some conditions about the nutrient. Is that kind of what they're talking about doing? Kind of trying to figure out what the rate of growth of the.
Yeah, I'm not sure what the whole idea, I know, was to possibly start using alum. That's what they wanted.
Oh, okay.
Yeah, so I don't know.
Okay, so trying to figure out how rapidly that alum that was added would maybe be covered up by new material that was coming in or something like that.
Right. I mean, they're moving, so I'm not sure how that works.
Yeah, I think part of the process, and I'm not sure I have a lot of depth in this area, but there are two elements to the phosphorus, and the one would be contained within the lakes as opposed to phosphorus coming from elsewhere. And I think they're trying to determine that because the feeling evidently is that the use of alum would be dependent on that. If you have a lot of, let's say, phosphorus captured within the lake, it might be less effective. So I think that's what they're trying to determine as a basic question.
Right.
I have a question for you before you go, if you don't mind. And if you feel it's too big a question to answer in this group, just send us an email or something, Paul. But I recall a few years ago, there was some testing done in Lower Camelot Lake, and it was really to try to identify the source of the nitrates in Lower Camelot. I think you were involved with that, right?
Yeah, you might be referring to one of our research interests is, I think it's specifically about the septic system impact to lakes. Yes, and I meant to sneak a comment in there related to that, but we septic systems, conventional, just a normal septic system, does release nitrogen as nitrate into the groundwater, and we know that, and a lot of studies have been done over the years, exploring how much denitrification, for instance, might actually occur. But generally, I think we could think of in a conventional septic system, you probably have nitrate containing water that's leaving that drain field and going into the groundwater, and then in this case would probably ultimately go into the lake if that drain field is draining to the groundwater is flowing to the lake. And our question was also interested in the phosphorus question related to that, because phosphorus, we know, is, and of course we've said it several times here, is a lot more reactive than nitrate. And so while the nitrate would easily probably move vertically through the soil beneath the drain field, what is the question of, what about the phosphorus? Phosphorus, of course, is really critical to biological productivity in lakes. And so if there was any breakthrough of phosphorus, that would really have some serious implications. And so we still have that research project is still ongoing. We're actually looking at a site this year, a much bigger. One of the challenges is actually finding the water that comes from the drain field and goes into the lake. And so that's what you're talking about, Don. We poked around on a couple of sites on Camelot and tried to identify areas where we thought that maybe the septic would be coming in. We didn't really see any real strong signatures in some of that preliminary testing. And so we have actually moved some of that research to a site where we have a much bigger mound system associated with a campground. And so we're doing some of that monitoring this year. So hopefully we'll have more to report on what we're finding for the septic system, nitrate and phosphorus. We got some samples that we collected this fall, so those are still being analyzed. So hopefully we'll be able to report more once we get into winter. And as part of that study, one of our indicators was the use of artificial sweeteners, as we have the ability to measure that in the laboratory. And so we've, once again, thinking about complexities, there's a lot of sources of phosphorus, there's other sources of nitrate. So using the artificial sweetener as a rather unambiguous indicator of a septic influenced water flow path was one of the research tools there. So as soon as we will be putting together a first year or a progress report on that. So once I get that, I'll share that with you.
Okay, and then one quick question, and you can just answer it at some later point through email or whatever, but we introduced nitrate testing to our lakes a couple of years ago as part of that citizen lake monitoring, which is primarily phosphorus based. And I'd appreciate a recommendation about what additionally you think we ought to be testing for moving forward. So
Yeah, no,
you don't need to answer it now, Paul, because I know we've taken a lot of your time.
No, I'll keep thinking about that too, Don. Because obviously that pattern of nitrate that we pointed out there does show that if you really are interested in tracking nitrate in lakes, it probably doesn't. There's some utility in knowing what the concentration is in August, but really the more important concentrations are probably what you measure in April and May and June. But yes, we should talk more about that.
I have one more quick question. So you said that the phosphorus was 3,300, and then the nitrogen was 416,000 pounds per year.
That's what we calculated in that 2017 study, and that report should be available. I don't think those numbers were a lot different than the results that Bill James, who was with the Army Corps of Engineers at the time, and our group had commissioned a study with him and others in almost 20 years ago, I think. And I think those numbers were relatively similar to the numbers in that study. But yes, that's right.
So that's really high, really? What is it? How does that compare to other lakes? Is that off the charts? Is it normal?
That's a good question, because in the one hand, if you think about the size of that watershed, it's not, on a pound of phosphorus per land area basis, that's not a real high number, right? 3,000 pounds. That's a lot of phosphorus, but divided by say a 65 or, I'd have to go back and look specifically how big the watershed was from those 3 monitoring locations where that calculation was based. But on a per acre basis, that's not an enormous number relative to others. And that's not surprising, because that's a relatively sandy watershed, relatively permeable soils. And it does make us think a little bit about, okay, we do need to kind of keep track of groundwater phosphorus, which we typically don't think of as being that high. But is that being changed over time? Something to certainly monitor, or something to think about. But also, think about those areas in the watershed where we really do see overland flow runoff, especially near streams, near ditches, near shore, areas where we're going to generate that runoff. Those areas probably become unusually, relatively more important, because we just don't have a lot of those areas, overall in the watershed. The nitrogen, on the other hand, that's a pretty big number. And that would be bigger. We do have lakes that are that are comparable to that, small, lakes that have it, but that's a lot of nitrogen compared to most lakes in Wisconsin,
Thank you.
on a per acre basis. And that's, it simply reflects the fact that there's a lot of relatively high groundwater nitrate levels that are moving into those ditches and carrying relatively high nitrate concentrations in the water in those streams and ditches.
Thank
Well,
you.
I hope this is just a start. I'm happy to, you've given me things to think about here, and I will think about it, but I would encourage you to reach out, or let's find some other time to keep talking about this.
Thank you very much.
Yeah, it's always a pleasure. Thank you.
Very,
Every conversation, I learn something. Yeah.
Yeah, and likewise. So I know it's a system that has some really unique features, and I think we can learn a lot about the science of lakes and the science of nutrient movement across land by digging into some of these issues in your watershed. So thanks for the opportunity.
Oh, thank you.
thank you very much.
Next item on the agenda is status of the 9-kilometer plan and the resource. And I don't really have anything to report. Anna, is there anything you can share?
Yeah, so there have been a couple of interviews for the watershed agronomist position. Of the interviews that were held, nobody really qualified for the position. We have had other applicants, so I think the job posting is still open right now. There will be more interviews, so we're hopeful that there will be a qualified applicant within the new set of applicants. So once that is, once the hiring process is underway, I think I spoke with Don a little bit through a meeting about kind of when the new hire starts, bringing them on to the meetings, et cetera. And I think what we should do is maybe in the December meeting, kind of outline the goals of the 9 key element plan and see where we're at, and then maybe do an outline for what we would like 2022 to look like, if that's a possibility. And then maybe December of 2022, we can refer back to that kind of outline that we did and see where we were at and what we did in the year. So,
Sounds good. Thank you.
yep.
The other item, Rachel, are you still with us?
I am indeed. Can you hear me?
Yeah, I can.
Good
Yeah.
deal.
So next item on the agenda, what we wanted to accomplish, Rachel and I spoke the other day about maybe bringing some focus back to that capacity building exercise that we did with Eric Olson, with the hope that during our slow time, the winter time, we can give that a little bit more attention and maybe put a plan together for, let's say, springtime once we launch it. So, Rachel, can you go through some of the key points with us?
I certainly can. Yes, I'll just get that pulled up here. Okay, is everyone seeing my screen all right?
Yes.
Yes.
Good deal. All right, so we all remember this strategic planning session that we did, gosh, what was that now? 2 months ago, 2, 3? This was a follow-up from the presentation that Eric Olson did with us. And like Don mentioned, we did a good amount of work with it up front. I did go in and kind of update things. So as you can see, a couple of our goals here are highlighted kind of a deep green. That indicates that we have really started on those pieces and that stuff is rolling. We are moving along on those. The ones that are still pale here, we have not. So again, like Don mentioned, we'll just kind of refamiliarize ourselves with this, go through it, I don't think this should take more than, 10, 15 minutes or so, but as we do, if you see something that requires an additional detail, any kind of, commentary that should go in the notes, please stop me and we'll get that taken care of. And then as we move forward, I'd really like you to kind of think, okay, what are those areas that we really want to start thinking about to develop during this kind of slower winter season? So then, when that busy time come next summer arrives, then we're ready to hit that ground running. So our first goal at the top under our category of membership, number 1 was developing that mechanism for regular mailings. And so this comes along with applying for the grant that we've just submitted, thanks to Dave and all the group that pitched in to make that possible. So that's moving forward. And then a lot of these action items below, stockpiling content, be thinking about that. Like, for example, like I took pictures at the Owen Cranberry visit, for example. That's an example of content. So, we have pictures, we could write up a short article, just like a quick 1-page type thing. That would be an example of something that we could kind of start stockpiling for newsletters to let folks know what's going on. So, kind of just be thinking of that as we continue to attend more events and things. If you happen to take some pictures, then maybe write up a little blip and send that to either Dawn or Karen, and we can kind of keep that together in a folder. And then we're also looking to seek out a more formal template for our newsletter and then gather those mailing lists. Again, another part of that grant application. So moving on to our second goal, we did start discussing the idea of creating kind of a social media platform for the 14 Mile to try to get some more word out to the broader community, gain a more diverse range of ages attending these meetings and aware of the watershed group. So that is on our radar. Again, from our last discussions, it sounds like that's kind of something we want to worry about a little bit down the road. It's certainly not a primary goal right now to worry about that. But again, things that we can start thinking about is, stockpiling that content. If you happen to be out on your lake shore or at a beautiful spot on the lake or an event at a local restaurant, something like that, snap a picture if you see an opportunity. For example, if you're helping Karen with the Winter Farmers Market, great opportunity to snap some pictures of folks talking to Karen or whoever else chooses to be there on those days. And then, we talked about developing kind of an outreach strategy for that. But again, I guess I'll open it to everyone here. How do you feel about kind of tackling that this winter? Is that something that the group would be up for kind of starting?
Well, I think what you said about the farmers market would be the only, I don't think we're gonna be doing farm tours then, or I'm not sure what other events we'll be going to. But Instagram, from what I understand, I'm not a big, Instagram person, but basically it's pictures, it's visual, it's all visual. So we'd have to, I don't think we want pictures of meeting. I don't think that's gonna be very interesting. But I have to tell you, I am making progress. I have a new phone. And I got the Pro 13 Pro, so I can take an actual good picture. So I'm working on it. And I'm also going to meet with my son's girlfriend and soon, who actually does this for her job. She does social media. So I will pick her brain when I see her and try to get information on that. So I'm working on it, but it's a slow process. And I don't have any pictures right now.
Wonderful. I would suggest then throughout the winter months, how about, we all just kind of make it a group effort to start taking more pictures. When we have meetings, any kind of events on the lake, even just pictures that you find beautiful of your lakes, that's a lot of, I noticed the Packers Instagram does a really good job with this. They'll just take great pictures of the lake. It just helps people grow in that appreciation. With your watershed community, that's a huge thing that you all have in common, is a love for that resource. So, emulating that is definitely a way to gather followers and bring people together, because it's that unifying sense of community. All right, moving on to goal number 3. So seeking out demographic data. So I noticed that Dawn, you had Drew coming to speak with us next month, correct?
Yes.
Good deal. Okay, so that will be wonderful to have him on. So that's gonna really start moving that goal along. And then this one here, the seeking out census data for Adams County. Have we made movement on that? I wasn't quite sure.
As far as, has anybody pulled out the census data? Is that what you're asking?
Correct.
Anna, do you have access to it?
Not when it comes to census data,
Do you know who would?
somebody at the courthouse for sure. I can get a hold of some people to see who would have census data.
Would you mind, Anna? That would be wonderful.
Yep.
Okay, well then I can go ahead and we'll make that green then. So we know that's happening.
Bob and I are doing is try to identify the demographics of our community generally, which obviously we're part of Adams County. So that would be helpful to have as well. I've made some contact with Jamie here, more about our local demographics than about Adams County, but I think the Adams County information is very interesting to have.
Don, I had a little bit of trouble hearing you, but from what it sounds like,
I could turn the mic on, that would help. I was explaining that Bob and I we're looking for some grant money. And so we're putting together some socioeconomics to kind of represent our story. And so one of the things we're looking at is demographic information regarding our local community here in Rome. And I think some of the info that Adams County can offer would be helpful as well. So it's in process. Honestly, it's kind of a slow process. So far, we'll share what we have, and perhaps the Adams County data could be shared with us too, because I think that's part of it. So, did you hear it okay, Rachel?
yeah, that sounds wonderful. Okay. All right, moving down to our next category of organizational growth. One of the goals we had was bringing in young business owners, and this was kind of in the middle of the road for priority. This is something that, again, I'll open up to the group. How do you feel about maybe putting this on the agenda to begin discussing this winter?
Yeah,
That's a good idea.
Okay.
How would we get that information like for the young business owners? I mean, that's pretty specific.
Well, I know we threw around the concept of a business owners association in your area. Are we aware of that?
I think so, and I would say that the information I have is not real current, but I think it was probably a year or two ago, I did a presentation on the 14 Mile Watershed, which was then a committee to the Rome Business Group. And I would guess there were half dozen people, like Lori Pritzel, Mike from, what is it, DSM, or DCM, and a few other people were involved. And I'm not sure how large a group it is, but I think because Mike was the former leader, president of that group, he might be the first person to start with, or maybe someone from Tourism Bureau, or Jamie, our town administrator, might know that.
There's also a Chamber of Commerce for Adams County. I do know that. I mean, are we branching out to Adams County? Because there's going to be that resource. I mean, I guess it's up to us.
Yeah.
Okay. Yeah. Well, I mean, I can contact her and ask her if she knows of any group. Ask for that.
Well, Rachel, these are going to result in some to-dos, right?
I apologize. My dogs are running around. I took me and myself for a minute.
Yeah.
All right, so
That's
says
a
here.
Small Business Development Center.
Small Business Development Center out of UWSP is a great resource.
Oh,
for that
okay.
data.
Okay, that's really good. Thank you. So it's UWSP we contact?
Yeah, and I can send Anna, I can send you the contact for that because
Yep.
when I was in there, they have a what they call an entrepreneurial training program, and I actually was in that for my business, and it was wonderful. And they are so connected across the state, and they can pull up that data. They can tell you the demographics of the data. They can tell you are they women owned or is it in a socially economically disadvantaged area. There's a lot of great marketing data because that's they want, and the census data too. I heard you talking about census data. They pull that regularly and they give that to young entrepreneurs so then they know how to market and advertise to their demographic in their region. So they are very connected. I highly recommend them. So Anna, I'll send you the contact info for that too if you want to share that with the group.
Yep, for sure. Thank you.
That would be wonderful.
Yeah.
Okay. Good deal. We'll get going on that. And then let's see, moving on down here. We'll kind of leave the rest of those action items for now. Just as we get the ball rolling on contacts. The next goal on the list is seeking out additional perspectives for board members. So this was low on the list for priority. So any thoughts we want to add to that one?
We added a new board member, so,
Yeah, we did.
right, so,
We did indeed.
yeah, so that's,
And
I guess we're doing it.
we do have a, if you will, a process or procedure being developed right now about how we add board members and how we determine what our current needs are. So we're trying to make that a little bit more process oriented, if you will. And so I think that probably relates to that whole flesh out board needs kind of a discussion.
Wonderful. Okay, let's see here. So we'll give an update in status here. All right. And you mentioned that this is kind of a structural process that you'd like to implement.
Yes.
Does that adequately state that structured process for identifying board needs being developed?
So
Okay. Wonderful. Okay, and then we did start on the idea of, again, different meeting time, different location. Now I know we talked about this primarily once we get kind of back into the busier season. I think is kind of where we left that, but any discussion on that?
yeah, I would just add that in the agenda, when we set the next agenda date and time, one of the things that I've suggested is that to-dos for 2022, the grants, capacity building, and then also the varied meeting schedule to really deal with just that very topic is, make the meetings more about our community than it is just about, a half dozen or so of us who attend the committee meeting. So it should have more appeal than that. So that's something to be discussed in December at that meeting. And I don't plan to really be a direct part of the meetings from January through April. And so I just want to kind of impart some of those ideas so that whoever's going to run the meetings can deal with some of those topics as well as the ones here. So it's in process, and I think we'll be talking about it in December. Rachel.
Wonderful. Thank you for that. All right, and then moving to goal 3, planning social events for members. We put this as a high priority because you guys have to have fun too, right? So we mentioned we could create a list of potential locations as regular meeting spots. Boat lake tours, things like that. Obviously not going to happen during the winter months, but something to think about maybe as we start to approach springtime. All right, and then moving down to relationship building. So our first goal in here was attend wildlife and fisheries meetings. Action items included developing kind of a list of who. So we definitely got started on that. We've got quite a list going here. And then inviting some of those representatives to meetings and developing an appeal for those folks to be part of the 14 mile. So anything to add there? Okay, seeing none, we can move along. Goal number 2, make a point to attend local agricultural events. So kind of developing that method to stay current, and that is tough to do, right? Because, you know, who's going to keep it up, right? That's a job for somebody that, you know, is on top of all the other stuff that you have to do. So I really think, you know, a good method is just keeping everyone in the know. I mean, the email list is really a powerful thing for getting the word out. You know, Dawn's been using it very well, and you know, moving forward, you know, if all of us make the effort, if we hear of something, to just make sure we're keeping us all in the loop, I think really is a pretty suitable method. In terms of upcoming events, you know, obviously things are slowing down now that the growing season is ended. However, I do know that the Farmers of Mill Creek will have an early December cover crop field day, a bus tour. Usually Rick Georgeson, and I think Scott Bordeaux, you've attended a couple of times as well. So that will be happening early December, just to kind of put that on your radar. I will be attending and helping out with that. So if you need a familiar face, please let me know.
Hey, Rachel, can you send us the announcement for that? Some of us used to attend. I've not seen an announcement in probably the last year or two. So if somebody's got it, and if you think there's an open invitation, send it to us. And
I certainly will. Yeah, sure thing, Don. I haven't quite gotten it. Ken Schrader of Portage County Extension is kind of the coordinator along with the farmers of the group. So as soon as I hear from him, then I'll send it out. All right, and then moving on to goal number 3, developing a pontoon outreach event for watershed members. And this is low on our priority list. So, you know, really the biggest action item there that we came up with was asking ad partners what a suitable time frame would be. And so, of course, you know, this would be most likely during those summer months, right? You want it to be nice enough to show folks around the lake and not be freezing. So that might be something we want to just kind of keep on our radar for springtime. And then I think we just got a couple things down here for programs. Our first one is build a relationship with local schools. That is low on our list. I know that Karen has started that. Anything to add there for now?
Well, I continue to email Keith. I'm gonna have to call him. I know he's busy and he's probably got a lot on his plate. I've been trying not to, you know, impose on him. I don't want to be a nuisance, but I will probably call him.
Absolutely. I will let you know that right now I'm working with Mike Schoenfeld, the science teacher at Nakusa. And yes, we're trying to get their prairie areas reseeded, and we're hoping that it's going to be more of a community event. We put in for a couple of grants to get some materials. So the students will be growing up seed plugs as well as getting a lot of seed. They have quite a few acres of prairie areas. Currently the prairie areas are, you know, they're not real diverse anymore. They've got a lot of invasives moving in, so they really just need to be redone. And he does a lot of really interesting coursework with his students with, you know, trapping small mammals for various, you know, population studies and behavioral studies, and then also, you know, working on invasives control and ecosystem management, you know, really cool coursework. I wish I could have taken his science class when I was in high school. But you know, what a neat opportunity for them to have, you know, to get to see how, you know, you implement a prairie. And that's going to include, you know, burning, and the no-till drill from Wood County is going to be donated for that. So I will keep the group posted as things move forward. Those plantings will take place either this coming spring or the following fall. And it might be something to piggyback off with the Healthy Lakes plantings. If, we want to get the word out, if it, we can make this kind of a community learning event, then maybe Lakeshore folks would be interested in coming and either, seeing that burn or, just kind of learning a little bit more about those prairie ecosystems.
Would you mention to him that if he does that, I mean, he's gonna do it with you, see if I can come along and take pictures and, use that for our social media?
Absolutely. Yeah,
And
will do.
Also mention that I've been, I'd like to get a hold of him. I'll just email him, but if you mention it, he might then respond.
Yes, I certainly will. And I, right now, with school being in full swing, it's usually about a week of lag time. Well, he'll get back to me. So don't be offended if a lot of time goes by.
It's been a month. They usually get back to me within a month, but by then, the momentum is kind of slowed down.
Mhm.
And
I will
actually,
certainly mention it.
I actually forget what I wanted to talk to him about after a month. So anyway, yeah, if you could just get my foot in the door, that would be great.
Will do. And then the last on the list was developing family-friendly events. Again, low on our priority list. That is, a lot goes into that, right? Bringing in help partners, volunteers, understanding the desires and needs of these various, families that could be interested. So, again, putting this on your radar, something to probably think about more towards next year. But it might be worth discussing as we start to get into the late of winter. And then that brings us to the end of our list. So that is our wonderful list of goals. We're definitely making progress, which is wonderful to see. That's the whole point of doing this, right? Is to kind of keep us moving along a good path. So I will send this updated version to Don, and he can shoot it out to the group. And then we'll just kind of keep doing these check-ins every now and then, just to make sure we're still moving along.
Thank you.
Thanks, Rachel.
Of course. And I will say I am going to have to hop off because I got to get on the road back to Wisconsin. So Anna, I'm going to send the host over to you, and then you can, continue the meeting as long as needed.
Okay, thanks, Rachel.
Yep. Thanks all.
Travel safe.
Yeah.
Will do. Thank you.
We're about 10 to 4. So committee reports. Karen, you want to start?
Okay, well, basically, I've gone over a lot of this stuff already. So basically, I actually thought I might take up working on the 9 kilometer flyer again because we lost Jason. So I think maybe I can work with Anna on that and just kind of, I'm not going to do anything quickly. It's going to take me time, but I'll try to work on that slowly and see if I can come up with something. Because we're not going to get a grant like yesterday. So maybe if we get that out and get it into our booth for spring, that would be great.
Oh, yeah.
So, and then as far as the educational programs, like I've said, I've been emailing regularly. Keith at Nakusa, he's obviously very busy. He does get back to me, but then he said, he doesn't have time right now. So I'm going to, like I said, call him and hopefully I'll be able to, but I'm working on that. Promotional booth, basically getting more information out. That's all we're trying to do, is get more brochures for our promotional booth. That's about it.
Bill, Watershed.
Right, upstream testing is going well. Our next outing is November 17th. We plan to continue upstream testing through the winter, weather permitting and ice permitting. We'll take flow measurements where we can and continue to do the sampling and the sound oxygen testing and so forth. With respect to in-lake testing, we finished all of that testing in early October, and we'll resume again in May with the CLMN testing and of course the additional nitrogen and phosphorus testing. The CLMN testing. Dave and Colt and I went out and looked for bugs, last Thursday? I guess, did the biotic survey, and I think we found 9 different kinds of critters. So that was part of the Water Action Volunteer Program. And I will try to get access to SWIM's database to put that information in. And we anticipate we'll be probably doing that twice a year, spring and fall. So we'll have to get the net out again, Dave, and May or whenever.
Yep, thanks to Colton for coming along.
Absolutely.
He probably reduced our effort. Increased our efficiency by double at least.
He knows his books, that's for sure.
Didn't need to key things out.
Last item, internship. We've had 7 people respond to the appeals that we've made in various places. I've interviewed them all over the last couple of weeks. I would say that we have 3 very strong candidates. And at this point, we'll have to determine, what our surface water grant budget will allow in terms of, can we make offers to 2 or possibly 3 of them, and to coordinate with Kane's plans for testing next year as well. So hope by the end of this week to be making offers to at least 2 of them. I would think. So, questions?
All right. Okay, thank you. 8, grants.
I got the education grant submitted on the 29th of October. So we ended up with a final budget in the range of about 13,000. We're looking at 5,000 in grant money. And of that 13,000, we got about 2,500 pledged from Town of Rome and Tri-Lake. So we're looking at over the 2-year course of the grant, we're looking at still needing to raise about another $6,500 to accomplish our very ambitious outreach plan. So Healthy Lakes, I submitted that through Tri-Lakes on the 28th of October. Ended up with 6 land owners submitting 12 projects, so that was pretty good. Got kind of off to a slow start last year with interest, and it always picks up right at the end. So that's about where we're at with that. Clean Water Cooperator. Right up until the end of the season, we were still trying to recruit folks at the farmers market to have an interest in displaying those signs. So still do that over the winter. There's no reason why we can't give out signs, and the ground might be frozen and they can't be put out right away, but certainly we can keep up the interest in that. So anything from Don or Bob regarding legacy?
No, it's on me. I need to get the demographics together so that we can really build our appeal, if you will, before we can identify how much money we're looking for. So it'll be a long process. It's going to be a long.
That's all I've got, but thank you.
Thank you. Barb's not here, but is there a treasurer's report, Bill?
Yeah, just briefly, we have cash balance of roughly $4,800. And since the nonprofit was formed, we've received about $6,500 in donations. I guess I'll have to talk to Barb whether she wants to perform a internal audit. So I can kind of get ready for that. So I'll work with her on it.
Thanks, Phil.
Yeah.
So in terms of partnership development, I will work on identifying some speakers who we might to schedule during the winter months. We've talked about the groups and awards. If you have some ideas about what groups we work with or key individuals we might want to give an award to, let me know. I've got plenty of award stock back at home, and I know exactly where to get the frames, so I'm good with that. Alliance status and the status quo. Any questions about any of that? Any quick link updates?
We're trying to identify somebody on Lake Sherwood to refill the resignation with Tri-Lakes. So we do not have Tri-Lakes board representation for Lake Sherwood right now. So we're asking interested folks to come forward and try to recommend somebody to Tri-Lakes who can recommend Lake Sherwood. Interest in putting in some time and is interested in lake quality and representing Sherwood.
And they vote on it, basically,
It's an appointed position, so that, yeah, so
they vote on it.
The board does. Tri-Lakes board does.
yes, Tri-Lakes board.
I don't think they vote on it. They appoint somebody from the lake. I've never seen a vote on the member other than when they tried to put 3 people from Camelot on the board. Other than that, they're appointed by her. I'd like so. Normally, when you're running, you get a sheet for 25 signature. And
Yeah, that would take, yeah, that's the normal process to get on the ballot, right?
the only time I've seen a vote is you got more than one candidate. You got one candidate, you're appointed to the committee.
So Dave, is there anything that we can do? It sounds like, are you having some difficulty finding somebody? Is that?
I put it out in the newsletter that just went out about a week ago. I haven't had anybody. No, I haven't had people knocking down my door. My email account just yet with offers and interest.
Well, we have that distribution list. I'm not sure it would be any more news than what you have on your.
I'm going to be following up just with the
If you need
broadcast.
help, just,
We have.
I think Jerry might still be with us. Jerry, anything new on the town or county?
I don't think
I
he
don't
is.
see
Oh,
He's
okay.
actually
Jerry's
not
not
with
with
us
us.
anymore.
He must have signed off, so we'll just bypass that. So, the next agenda date and time, are we good with December 13th, which would be our second Monday? Everybody okay with that? Same time, we've identified the speaker will be. And I had suggested what we might want to consider on the agenda. And, you know, it's open for suggestion. So, you know, if following the meeting, if you have an idea, shoot me an email and edit to the agenda. But so far, it's to-dos for 2022. Execute the grants, build capacity, varied meeting schedule. Outline the 9 element goals for next year. These are not necessarily things that we want to at that meeting, but there are things that we probably want to schedule into the winter months, right? And so,
Just add the wrong farmers market.
okay.
Talk about that, so I'll know where it is.
If we could preferably put off the 9 key element plan until January, that would be great.
Oh,
Just,
yeah.
well, just to go over the goals, not put everything up, just to put
I see
the
what you're
goals
saying,
there. So
yeah,
then, yeah, then it gives us a little bit of time to onboard
Right.
a new position and get them.
Do you think the new position will be? in
We're
place?
hoping,
Okay.
we're hoping.
Because that would be ideal.
Well, I think before we close, and item number 3 minutes, is that supposed to be 21 or?
Oh, I'm sorry. Yeah, probably 21.
I would say so.
Yeah,
Good catch.
excellent catch, and I apologize. I'm surprised that. Rest is okay.
I could blame it on my Chromebook.
You could.
All right, so, anything else? Otherwise, I'd entertain a motion for adjournment.
So moved. Second.
Okay, thank you, everybody.
Thanks, guys, online.
Thanks.
Thank you.
Sure. Anna, will you
Yes.
send me the copy of the, all right, Rachel, one of the two of you, so I can put it on the YouTube channel.
Oh, yep,
Thank you, the meeting.